So this is a question which I thought you will maybe get it all right and good, but it's okay. It's a learning curve, so we learn. Question 3, given that 6y is equal to x minus 6 and 2y plus 2 minus 12x equals to 0, you had to first actually find the angle. Now, the question is at the acute angle. So here is the first equation. In fact, what you have to do, you have a general form. You had to simplify it into what I call the intercept form. The intercept form, let me write it here. Intercept form is where you now have y as the subject of the formula. So for the first equation, let's take this as y1 here, this there as y2. So the first equation, you can see that you're going to have x over 6 minus 1. And then the second one, if you simplify correctly, so again, I should say, you're going to have now 2x because, sorry, not 2x, it should be 6x, okay? You are making this thing the subject of the formula 6x minus 1. That's what you're going to have. And you can see you've got actually lines that have got a positive slope. Now, this one here is the line y2, which has the equation 6x minus 1. And this one here is actually the line y equals to x over 6 minus 1. One thing that you should notice immediately is that these lines have got the same y-intercept. Same y-intercept. And this is actually now, therefore, your point of intersection. Your point of intersection. So without even further calculations, you know that your point of intersection is actually 0 and a negative 1. That's one thing that you should have probably noticed. Now, you have let's suppose you have plotted this by using the intercept method, dual intercept method. Now, what you will notice, guys, is that you are looking for this angle here. I'm going to circle it. I'm going to mark it in red. You see, that is the angle between the lines. Now, the tricky part here is that for you to get this angle, you needed to make those markings as I showed you in the videos. One, if I take the overall angle, this angle here as beta, and then I take this inner angle, never mind this line here, okay, never mind that line for now, and I take this inner angle here, the one in blue, okay, it's highlighted nicely in blue by GeoGebra. So if I take the blue angle, I can look at that as alpha. And then finally, I can look at this small angle here as theta. Okay, for now, forget about these values. Those are the answers. So let's forget about these answers so that you can see how we're gonna get this. So now we can see that we are actually looking for alpha. So alpha is, let me just write it here, alpha, you can see it is actually beta minus theta. Why? Because beta is actually the sum of alpha plus theta. That's the original equation. Now, do we know beta? Yes, we know beta. Beta goes, if we want beta, we are then going to say, well, tan beta is actually equal to 6 because that's the gradient of this line here. Do we know theta? Yes, we know theta. Tan theta is equal to 1 over 6 because that is the gradient of this line here. And that's all you had to do at this point, find your beta. So if we take arctan of 6, you realize that, okay, this implies that beta is 80.5 degrees. Then this one here implies that theta is what? Let's see here on the calculator. Theta is actually 9.5 degrees. Now, we said alpha is what? Beta minus theta. So what? Let's say 80.5 minus 9.5. This is 71 degrees. That's it. Now, we know our angle between these two lines is 71 degrees. Now, 3.2 then says, okay, prove that the bisector, right? The bisector has a gradient of 1. So this is now where we can now consider this line. Bisector, I've got two bisectors. One is for the obtuse angle, which is this one, never mind it. The next bisector is this one, and this is the bisector that we're looking at. Now, what you need to do is to consider, okay, for the bisector, I'm going to clear everything now so that you are not confused. What you need to do is that for the bisector, we're actually looking at this angle here. We are looking at this angle. Now, we are to find this angle. We know beta a little bit, we know alpha. Now, let's think, just to make it easy for you. If I've got this angle here in purple, and I want this one in what? Maroon. What is it that I can do? Okay, you can see that. Let's call this one in purple again. Let's call it beta. Let's call this one in maroon, and let me use that color. Let's call it alpha. And okay, we've got a beta already, so maybe let's call this one theta. My apologies. So let's call this one theta. I just want to do this so that you guys have a clear understanding. So what is the relationship here? Theta is actually the one in maroon, alpha. Okay, I hope you can see that. Plus, no, not plus. Okay, I'm the one now getting a little bit confused. If I take alpha plus beta, alpha, here is alpha in maroon. No, actually alpha minus beta is equal to the angle that I want, which is theta. Now I've got to erase this theta. That's not the correct theta that I want. I want this theta. I want this theta. Yeah, this is the theta that I want. And in finding that theta, I need to consider this small angle, and this small angle. My apologies for the confusion. So let's say the one in black is beta, the one in maroon is alpha, and the one in pink or purple is theta. So you can see alpha plus beta now is theta. That's the equation that I wanted. So we know this one already, but now we want this one. So question is, what should I do to find this angle here? Yes, that is the big question that I wanted you guys to think about. So you can see then that we can use the fact that since this thing is a bisector, then we cut this angle in two. If we cut this angle, which angle is this? The angle 71. If we cut it in two, then we have it here. So maybe I should say here, 71 degrees divided by 2 is actually alpha. Okay, so which is what I wrote here on the notes. Very easy, straightforward. So this angle will give us what? 35.5. All right. So if we round it off to one decimal point, or 5-4, whichever way, and then we can see that now if you were to add this and this small angle, you're actually going to get 45 degrees, which is what I have here. And we know tan 45 is actually 1, and that is why the gradient of this line is 1. Now, 3.3 was really a giveaway because you know already that is the point of intersection for the two lines. So you have the gradient, and so the y-intercept is a -1, and there it is. We are done solving this question. Guys, I hope you learn from this. We are moving on now to number patterns, which is another nice, fascinating topic. I'll catch you guys on later on during the week once you have gone through the solutions and you have understood them. Cheers.